Eason, and I am from Northern Arizona University. Currently, I am the REU intern working in Dr. Smee's lab. The focus of our lab is phenotypic plasticity, or how oysters change their shell morphology based on the introduction of predator cues, or lack thereof. In this video, I will provide you the details of my experiment.
A typical day in the lab will begin with the oyster shake. Every morning, these mesocosms are drained. The cages holding the oysters are gently rinsed, and the mud is pushed down the drain. The bricks underneath the cages are set straight. The cages rotated to provide each equal opportunity exposure to the food source, and the tanks are refilled. Once the cages are submerged again, they lie in wait for the afternoon shake. The tanks are not drained or rotated in the afternoons, only shaken. This is done twice daily to prevent the oyster larvae from suffocating. For my project, we started off with 4 tanks and 2 treatments. Induced tanks housed both oyster spat cages and blue crab cages. This allowed for the spat to be exposed to predator cues such as crab urine as well as crushed oyster juice when the crabs were fed. In the control tanks, these cues were non-existent. Once the cages aged to the 2-week mark, random sets of 3 tiles were removed from various cages in each tank and measured in length and raw crushing force. Also at this 2-week mark, we switched half of the cages between 1 control tank and 1 induced tank. This created 4 treatments: a control tank where oyster spat experienced no exposure to predator cues, an induced tank where oyster spat only experienced exposure to predator cues, a late exposure tank where oyster spat were not exposed to predator cues until a later life stage, and an early exposure tank where spat were exposed to predator cues in an early life stage but not exposed in later stages. The tanks were maintained in the same manner as they'd been prior, i.e., tanks housing predators were fed 1 crushed oyster per crab every Monday, Wednesday, and Friday, and each tank experienced the same morning and afternoon cleaning discussed previously. Once the oyster cages aged to the 4-week mark, the crushing process was repeated. This time, random sets of 5 tiles were removed from varying cages and measured in length and raw crushing force. You can see me applying gentle and consistent force to spat using a penetrometer, which will read out the raw crushing force in newtons, followed by measuring the length of spat shells in millimeters. The raw crushing force will be divided by the length to provide the standard crushing force in newtons per millimeter.
The purpose of my research is to answer this question: when can we start inducing oysters, and for how long? Oysters are vital to the ecosystem, and some benefits include providing nursery habitat to other species, shoreline stabilization, and water filtration. However, many restoration efforts fail or experience high levels of degradation. If we can pinpoint ways to strengthen oyster health, we may begin to lessen the failure of these restoration efforts, as well as enhance the benefits that oysters already offer.